Okay, on to numbers. So exact numbers. These are numbers that we know 100% for certain. That would be anything you count, right? Counting numbers. If I can actually count the fingers on my hand, I have 5. That is an exact number. That is not any estimation whatsoever. Also considered exact numbers would be precise definitions. So like the definition of 1 foot is 12 inches. Okay, so that is an exact number. Okay, that is important because then we're going to start talking about numbers that are not exact. Most measurements are not exact. 12 eggs in a dozen, that's like a definition. A dozen is 12 eggs exactly. All right, so these are exact numbers, counting, or precise definitions. Everything else, any measurement you make, is technically an inexact number. Okay, even if it's electronic things round their last number as well. So any measurement that you make is going to be an inexact number, have some level of uncertainty in it. Okay, so for example, a coin has a mass of 2.52 grams. If I put this on a scale, you might notice that that last number kind of wavers a little bit, and that is because the scale estimates that last digit. Another example would be a bottle of soda has a volume of 591 milliliters. Well, why don't I have it at 591.0 milliliters or 0.0000 milliliters? Well, I don't actually know those numbers. So how measurements are made is that you are always going to have multiple, or hopefully multiple, numbers that you know for certain, and then the last one is going to be estimated, and I'll talk about that more here in a little bit. So you should be able to tell the difference. If I'm looking at these examples here, tell me if they are exact or inexact or measurements. Okay, so we need to look at phrasing on these. So for example, a store has 35 bicycles on display. That would be exact. I can count 35 bicycles, right? The density of an object is found to be 1.8 grams per milliliter. I would consider this measured because found to be would mean that I measured it in the lab. Okay, so things in the lab are going to be measured some degree of uncertainty. 1 meter is equivalent to 100 centimeters. Well, that's definition. The definition of 100 centimeters is 1 meter. They are the same thing. That is exact. Planck's constant is listed in the book as 6.626 times 10 to the negative 34th joule seconds. That would be exact. Any type of definition is an exact number. There are about 454 grams in 1 pound. Well, that would be measured. It sounds like they are estimating, right, about 454 grams in 1 pound. If you actually looked it up, however, that would tell you the exact number. So there's a difference between exact and measured. Okay, now we're going to go more into measured numbers. Okay, any measured number, like I was mentioning before, has some degree of uncertainty to it. We are not 100% sure of all the digits in a measured number. So we need to count what are called significant figures. So if you break that word down, significant means important, right? So which numbers, which figures are important? Those are the digits measured that are certain or have a graduation line on the instrument plus 1 estimated digit. So this right here is a measurement. Say I measured a piece of wood and it was 5.213 centimeters. Well, I know for certain the 5, the 2, and the 1, and the last number is estimated always. Okay, so certain digits are ones that everyone would agree on. So if I'm looking at a ruler, everyone can agree that this was somewhere between 5.21 and 5.22. Okay, those are known numbers. The 5.21 I know for sure. Okay, the uncertain digit is the best guess. It is the last digit in your measurement. Okay, so the last digit in this one, well, this person looking at that piece of wood thought that it was at 5.213, but it might have been at 5.212 or 5.214. We're not sure. Okay, so the last digit, again, in any measurement is going to be your uncertain digit. All right, so here I've got a measurement. It's marked here at 2.55 or 2.5 on these 2 different rulers, but notice the 2 rulers are different. Okay, the more graduations you have, the more lines, the more precise your measurement can be, the more significant figures or digits you can have. Okay, so when I'm talking about certain digits, if you actually look at this first ruler here, my line, I know that that's somewhere between 2.5 and 2.6. So that 2.5 part is known. It is for sure between those 2 marked lines. Okay, now I think it's right in between those two lines. If you were looking at it, you might think it's a little bit closer to the left line. You might put 2.54. You might put 2.56 if you think it's a little closer to the right line, but I think it's right in between. So it's 2.55 to me. So that last digit is estimated. Okay, now if you're looking at the second ruler, it doesn't have as many graduations. We can all agree that this line is somewhere between 2 and 3, right? So it's 2 point something. Okay, so that is a certain digit, but I'm actually estimating that that's at about a 0.5. You might think it's at a 0.6 or a 0.4. So that last digit is estimated. So essentially, any measurement you make should have what you have graduations for. So however many lines you have graduations for. So for example, this ruler has graduations for the 10th place. That's this 5 right here. And then you estimate one more. So I estimated to the 100th place on this one. If you're looking at this ruler, I have graduations or markings for the 1's place. That's the 2 right here. And I estimate one more digit, or I estimated the 10th place in this example. Okay, so read what you have lines for and then estimate one more digit. All right, so we're going to do some examples here. Oh, I already put the answers on here, but give these a try. These are my examples, okay? So this is a piece of red whatever that's measured with this ruler and this ruler, okay? I can get a different measurement on these two rulers because one is more precise or has more graduations than the other. So the first one is somewhere between 4 and 5. I said it was 4.5 centimeters. It might be 4.4, might be 4.6, depending on what you thought. Those would be acceptable answers. Okay, that 5 was estimated. However, if I use this ruler, I can definitely see that it's somewhere between 4.5 and 4.6. So I said it's 4.55 centimeters. You might have said 4.54 centimeters or 4.56 centimeters. Those would all be acceptable answers because that last digit is estimated. Now, if you think something is right on that line, okay, so I know, well, it looks like it's right on the 3 to me. You can put a 0.0. Okay, so essentially, when you look at this ruler, I have markings for the 1's place, right, where that 3 is, which means I need to estimate the next digit. So I did. I thought it was a 0. So I put 3.0. Okay, so 0 is an acceptable number to put as your estimation. Okay, you should just always have one more digit than what you have markings for. Now, if we look at this graduated cylinder, and you guys are going to be looking at a lot of graduated cylinders this semester, water always does this little dip thing. It's called a meniscus, okay? So you always need to measure from the bottom of the meniscus. So how much is this based on the bottom of the meniscus, okay? So this to me, now I'm gonna look at my graduations, make sure I read this correctly, right? So this is a 6 and this is 8. So if I count the graduations in here, well, this one here is actually 7. So what each of these graduations counts for is a 0.2. Okay, so if I count up here 6.2, 6.4, it's somewhere between 6.6 and 6.7. Sorry, 6.6 and 6.8. So I said it was 6.7. I think it's right in between. You might have said it with 6.6. You might think it's right on that, and that's okay. That would be fine. That last digit is estimated. All right, so that's what I would put this one at. Remember to read from the bottom of the meniscus. Okay, so we're gonna look at this equipment. This example says, which measuring apparatus would you use to deliver 9.7 milliliters of water as accurately as possible? And then to how many significant figures can you measure that volume of water with the apparatus you selected? Okay, essentially, the more graduations, the more precise your measurement. Okay, so if you're looking at all of these, I would say that this first guy has the most graduations because it has a line for every 1's place. This one is for every 10's. This one is also for every 10's. And this one you can't see very well. This is a really teeny tiny beaker. Beakers are never very precise. You should always stick to graduated cylinders. So I would pick this first one as the best measurement tool, okay, to get 9.7 milliliters water. Now, if I needed over 10, I would have to use bigger graduated cylinder, but this one is correct. So notice it has lines for the 1's place, so I can measure 1 past that, or I can estimate 1 past that. So 9.7 would be a measurement you can make from this graduated cylinder. All right.